Tell me when, my guy. Tell me when.
We're here. We're here. We're here.
All right, we're here.
Yeah.
Yes, sir. We're back again with another live stream. What is it? Number 27? Am I right?
27. Yeah.
Yes, sir. Let's go. Number 27.
Sorry we
Right,
started
another.
late. That was on me. That was on me.
All good, buddy. All good. All good. We're all good in here. So, we're excited to be here yet again. Another live stream. Another LeetCode. Painful LeetCode. It's a love and hate
I don't know.
relationship.
I don't know if it's gonna be
But,
painful today.
really?
It might.
You
It
think
might
so?
be a. It might be
All right,
good
we'll
today.
see. We'll see. We might be good. All right, we'll see. We'll see. We'll see. But I'm ready, my boy. I'm ready. How
Oh,
how
I
you
just
been
realized I don't
doing?
have
How
my
you doing?
background on. Give me a second. I've been
Ooh,
doing good. I've been doing
bro.
good. I'll still talk. Give me a second.
Of course, of
Let's
course.
figure this out. Nope, not that one. This one. All right. You said how's I doing?
Yes, sir.
Been doing good. School started, so gotta get back on track.
I get you. I
So
get you.
school started, and then kind of figuring out like the classes, like which one's gonna take more time, which one's gonna like I could maybe not. I mean, this might be bad to say, but which one can I like not put as much time
Yeah.
as I need to? Like I know it's gonna be easier. Um, so stuff like that. Just trying to gauge it out. Um, but other than that, I think that's it. Tomorrow's Labor Day. No school.
Tomorrow's
No
Labor
school
Day.
tomorrow. Do you know what Labor
Yes,
Day's
sir.
for, or like what is
I
it
mean,
for?
I think it has to do with like the. It's like Labor Day. It's like a celebration of the people that work. I
Uh,
think that's why. I think that's why they call it the Labor Day. Because like the people that do labor, right? So they give it a day off.
okay.
And I think most businesses close, but I know and some schools close, but some of them don't. For example, my girlfriend's university is not closing tomorrow, so she has school tomorrow. I'm making
Uh,
fun of her, you know, because tomorrow I'm gonna wake up, I don't know what hour, but she has to wake up at 6 or 7,
and
bro.
she's gonna be already up and running.
Yeah,
Algebra,
algebra.
whatever
You know,
she's taking.
yeah, she's taking some weird classes right now. And she's gonna be suffering over here. I'm just gonna be waking up like at 10, 9, maybe
Yeah,
12. Who knows? Depends. But
yeah.
yeah, I think it has to do something with the workforce and that stuff. I'm not sure, right? But I'm assuming. I'm basing myself on the name. Would have heard here and there.
Okay,
But yeah,
really
yeah.
cool. Let me see. What else should we talk about? What else? What else been going on?
What'd you do
Mm,
this weekend?
what I do Friday? We had like a meeting.
Uh huh.
Um, and then what else did I do Friday?
I don't
Oh,
know.
then I played some games Friday. You
Woo!
know, Overcooked. Did I already talk about that before?
Yes,
Overcooked.
overcooked. Yep, yep, yep,
Yeah,
yep. Ooh,
been playing
man.
Overcooked, and then um Saturday we had another friend event that I went to. So we went shopping. I rarely go shopping, right? So I needed some new clothes. So you might see me Tuesday with some fresh clothes.
I looking
Something,
fresh, bro. It's
something,
gonna be
something.
walking up straight and everything,
Yeah, you never
Talking
know.
for
We'll
like
see. We'll see what
being yes
happens.
sir.
Yes, sir.
Miss- Mr. Carlos,
I'm gonna be telling you to take pictures of me and stuff. But yeah,
Yeah.
got some new clothes, new shoes. I know I had some very beat up shoes. I'm one to wear out things to the last minute,
Yeah.
right? Whether that's to save money or because I still think they're useful, like the shoes. But these shoes, they're done. Like
You're done
they're
for.
torn up. Like they're not torn up, but they're dirty, and it's embarrassing that I was wearing those shoes for that long. Like I'm honestly embarrassed at myself. Um, but hey, shoes are expensive, man. Shoes
They
are
are.
expensive.
They are. They
So
are.
I got some new shoes. They look very similar to it, but hopefully in the coming up weeks I could get to buy another pair of shoes that are a little bit different, just so
Uh-huh.
I get some variety. But um,
Woo!
yeah, so I
Man
went
going
shopping. Huh?
man going to Fashion Week over here.
Yeah, you never know. You never know. We'll see what
Yeah,
happens.
I
Me
see,
and
I see. I'm
oh,
like,
I mean, hey, you got the haircut. You feeling
I got
fresh with the
the haircut,
haircut?
bro. I was like,
Mike,
ooh.
Mike, one of our other buddies, he's always looking
Uh-huh.
fresh. He always got something
Oh,
down.
he
So
does,
I gotta
bro.
step it up. I can't have y'all like stunning on me like that. I need to step it up. You know what I'm saying? So I
I
have to
get you, I
step
get
up my
you.
game. But other than that, after the shopping, well, we did thrifting. I don't know if you ever been thrifting before, but I,
No, I have not,
yeah,
but I think
I,
I know what it is.
yeah, I prefer doing that because you get to find like a lot of like cheap stuff
Mm-hmm.
that's
Mm-hmm.
cheap, but like you could still get value out of it.
Mm-hmm.
So not thrifting in a sense of like finding like people say vintage clothes and
Yeah.
like to find like the gyms and like the hidden gym shirts or whatever, you know what I'm
Uh-huh.
saying, like, and
Yeah.
then they resell them, or like none of that, but just
Yeah.
honestly like shirts that I could wear like
Like
around the house
discount
playing
clothes. Yeah.
basketball, anything like that. um so I like thrifting. I think it's pretty nice. I don't care if they're from a thrift store or whatever. I mean, if
If they look
if
nice,
they look good and the quality is good,
they
I'm not
look
gonna
good.
buy nothing
Yes,
trash,
sir.
like, but if
Yeah,
the
of course,
quality
of
feel like
course.
it's gonna last and it's $1, I'm gonna purchase the
Just as a
thing. Like
bargain.
what? I'm
Easy.
not I'm not gonna go pay $15 for a shirt that's the same quality, and then it's still gonna tear down on me later down the road.
Yeah.
So you know what I'm saying? So
Yeah.
thrifting, and then we went to North Star Mall, and that's where I got
Mm-hmm.
pants and then my shoes and stuff like that. So yeah, I don't buy pants from thrifting. I guess that's a boundary of mine. Like
Uh-huh.
pants might be a little bit different. I think shirts are the easiest because you could go small, medium, large, extra large. Like it's easy to find your size. Pants, you got the waist, you got the length. Like, and when you're
Yes. Yes.
thrifting, everything's random. So
Yeah.
to find something you like and have it being your size is very difficult. Also, on
Oh
top
yeah,
of that, I
100%.
don't want to wear someone else's pants. That's just me. That's just preference.
Fair enough. No,
So,
I get you. I
and
get
people
you.
even have their long johns on the shelves too. Like, I'm not I'm not going to do that. We got a comment. Sorry if you mentioned this a while back, but a comment said,
I think it's liner.
Liner. They said, how is the insanity level going up? How does that work? Well, basically, what happens is whenever we're working through a LeetCode problem, you know what? I'm gonna switch out of this thing. Let's switch it up. Whenever we go
Alrighty.
through a LeetCode problem,
Yeah.
which right now we're doing binary search, um,
Yeah. Also, whenever
we
you get the chance, can you
oh
share your
yeah
screen?
yeah yeah,
Yeah. Yeah. Take your time.
got you got you. Give me one moment.
Of course, of course.
Okay. So the way
I
this
got
works is that whenever we're doing a problem, usually after we finish it, we always want to update where our insanity level is at. So, for example, let's say me and Jose finish this in like an hour. That's a little bit timely. Like that's a lot of time we spent on it. More likely than not, our insanity level is gonna be pretty high. So it's a tally. We wanna see where we feel at mentally throughout the stream. And the rule is if we ever reach an insanity level of 10 each, then that means we have to end the stream. So that means we
you.
maxed out. That means we're done. Our minds can't focus anymore. We're stumped. So we decide to take a break once we hit 10 insanity level score or whatever, and the stream ends. So that's kind of what we got there. Um, it varies. So it varies. We could be working on a problem, and then when we're done with it, we say, "Oh, I'm at like a 1 out of 10 in an insanity level," and Jose's at like a 3 out of 10. Or usually I'm higher than Jose all the time when the insanity levels. So I'm usually like the 3 out of 10. Jose's like the 2 or 1 out of 10, and then we do another problem. We have to increase it again, so we update it. So maybe I'm at like a 5 out of 10. He's at like a 4. So that's kind of the rule with it. Appreciate the question.
Yep. Yep.
Um, well, I want to just finish what I was saying before we start. So we went thrifting, then we went to North Star Mall, and then from there, I think that was it. We went out
Woo.
to like downtown. We went out to downtown and chilled at a spot. It was chill, like just talking like friends and stuff,
Yeah.
and just socializing. So that was about it. Other than that,
Yeah,
that's what
that's
I
pretty
did
cool. That's pretty
today. I
cool.
went to Olive Garden, so all you can eat pasta, and then that was about it.
Sheesh. That's cool. That's cool, brother. That's fun.
Yeah.
Me personally, I went back to my hometown, spent time with my family, with my girlfriend. Barely came back today,
Oh yeah.
and
How was
yeah,
the how
barely
was
came back
the
today.
how was the road? How was it feeling?
It was pretty calm, pretty chill. Not there's a lot of trailers, of course, but not a lot of traffic, not a lot of anything. Pretty chill, pretty nice. Nothing too crazy. And
Hmm.
now I'm back, ready for some lead code, ready to kick off the stream with some binary search.
Yeah.
And yeah, if you're
All right.
ready, I'm ready, my boy.
Now let's get it, man. So, for people who are viewing right now or viewing later, we've done these past categories: arrays and hashing, two pointers, sliding window, stack. We're now on binary search. We got two problems for binary search. I hope it's easy, but I'm not gonna think. I hope it's easy, but I'm not gonna underestimate these problems. So
Yeah.
after that, then we go straight to linked list. We got another hard problem in the horizon. Uh, we just finished one right now in the sliding window. Um, so we'll see how that goes. But all right. So let's. I'm gonna open up both of the problems. I
Alrighty,
believe
all right.
this one was the first one, and then yeah, fine minimum. Okay. So let's get started, Jose.
I'm ready.
Do you want me to read?
Yeah, for sure.
Okay.
I'm down with that.
So this is 153 find minimum in rotated sorting array. Suppose an array of length n. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums equals 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. Another example is 0, 1, 2, 4, 5, 6, 7 if it was rotated 7 times. Notice that rotating an array um, one time results in the array blah blah blah. Given the sorted rotating array nums and of unique elements, element return the minimum element of this array. You must write an algorithm that runs O log n time. Okay, so example 1, if you have nums equals 3, 4, 5, 1, 2, the output is 1. The original array was 1, 2, 3, 4, 5, rotated 3 times. So it's sorted. Okay.
Okay, I think I'm
So
getting it.
then you got nums. Then example 2, you got nums equals 4, 5, 6, 7, 0, 1, 2. The output 0. The original array was 0, 1, 2, 3, 1, 2, 4, 5, 6, 7. It was rotated 4 times. And then lastly, example 3, you have nums equals 1, 2. You have nums equals 11, 13, 15, and 17. The output is 11. The original array was 11, 13, 15, 17, and it was rotated 4 times. Very interesting, I might say. Like, you gotta find the minimum number, but you find it by rotating it into its sorted array. Is that correct?
Mm, I don't think so. I think the sorting is just like a like a smoke bomb. Like it's just there to distract you.
Well, I think that's why they say you need to write it in O log n, because you can't
Yeah,
just say find the minimum. You gotta figure out to
it's it's
what do you
because
think?
O log n, that's binary search. Binary search is O log n.
Okay.
So I think it's forcing us to use binary search.
But we gotta sort it first in order to find the minimum.
Mm-hmm. But how do we order it? Because if we order it, it's gonna be minimum n.
Yeah.
N times log n. We can
Yeah.
have it n times log n. We just want log n. So what I think it's doing, because we're getting the input 34512, and we just want to find the minimum
Yep.
1. I don't think the problem necessarily is like looking for. I don't know, because I don't think the rotation matters. What do you think? What do you think?
Well, I mean, if we need to do binary search, we know it needs to be sorted. If they
Mm-hmm.
rotate them and they're not sorted when we get them, then we gotta figure out how to sort them to do binary search.
Mm-hmm. But what if we can do binary search in an unsorted array?
I don't see how that works.
For example, on this example, right?
Mm-hmm.
We got 3, right? We have 3 pointers in it. So we have the left, the right, and the middle, right? And we can say, and we're looking for 1, right?
Okay.
Well, we're looking for the smallest. We can say if middle is greater than left, right? That means that oof, ooh, let's see.
But also, that's not binary search, though, if you have 3 pointers.
Well, it is because middle is not like a pointer. It's just like the middle, like the target value. Middle is like the making the decisions. Does that make sense?
Okay.
Like if, for example, if it was sorted and I'm trying to find number x, right? And it say if x it's less than middle, I know for sure that x is gonna be to the left of middle. So I move the right pointer to the middle. You get me? Yeah or nay?
Possibly.
Possibly.
So you're moving. So if we take this to Excalidraw, do you
You
mind
want me to
sending me
get
a
you
link?
the?
Yeah.
I got you. I got you. I got you.
If I'm understanding this correctly, let's change it, dude. You know what Nightbot is?
Discord.
No, it's like for streaming.
Oh, yeah. I've seen. I think I've seen it. I think I've seen it on Discord or in live streaming, but I'm not sure which one.
Yeah,
What is it for? Is it for like
that's just
notifications?
it. Kind of just like um, yeah, it kind of just like just notifies the chat or whatever. Oh, I'm getting an error.
Are you
Do
getting
you see my
there?
stuff or no?
Yeah. I
But it's
think you
saying
should
like
be
the
good though.
fetcher every time I click.
Uh. Hmm. You want me to send it again? Let me see. Let me send it again. Let me
There you go.
stop session. Alright, I copied the link. Alright, I'm gonna send you another one. Hopefully this one works. Yeah.
Yeah, so far so good. All right, but
Alright, same here,
so
same here.
if I'm understanding you correctly, you're saying
Let's do right.
well, this is sorted.
Yeah, that is sorted. Right.
Let's do an
So
unsorted one.
unsorted. Well, let's do the example number 1. What was the example? I think it was 3,
Um,
4. 5, 1, 2, if I'm not
Yeah,
mistaken.
let's say that.
All right.
So you're
So,
saying pointers like this, or not pointers, but like the target or whatever.
uh huh.
You have obviously you have the length of it. You have the first index 0, so you could get these fairly easily, right? You're
Mm-hmm.
saying if this isn't the target that we're looking for, move it, and if this isn't the target, move it. Doing that at the same time.
Not quite. Not
Okay,
quite. Not
enlighten me.
quite. I think we're keep. My. I think what I was trying to say is that we're gonna keep the essence of the binary search, right?
Mm-hmm.
So we're here, and then we're like, all right. So I know for a fact that if um, if 3 is less than 5, I know that how do I say it? I don't know. Mm, do, do, do. Hmm. I don't know. I had it right now, but I forgot it. Because if we do 3 to 5, right? We
Uh
say,
huh.
all right, for sure. If 3 is less than 5, we know for sure that the maximum, minimum value that I can go is 3, right? Because I have no more values over here, right?
Okay.
You get me? So I know for sure the lowest value is on this right side. Does that
I
make sense?
don't. No, I don't agree with that
What do you? How? Why?
because if there's a 1 right here, what? Why are you assuming that there's not going to be a lesser value in this middle?
Well, because I think on the I don't know if you can go back to the problem.
Yeah.
It said in ascending order. Suppose the array is sorted in ascending order. So, like in essence, we're given an array, right, in ascending order from like 0 to 7, but that array got rotated x amount, right, and then it was given to us. If that makes sense.
Okay.
Yeah,
So
yeah,
how does that tell you that in between 3 and 5
because
the value is
because
going
I
to
know
be?
for sure because it's an ascending order. 3 to 1, that's not ascending. That's descending. It's going down. So it's never gonna be 3, 1, 5 because that's not ascending. Because the original rate was 1, 2, 3, 4, 5, but it got rotated 2 times. So now we have 3, 4, 5, 1, 2. You get me? It's still in an ascending order. Like you're not gonna have a 3, then a 2, then a 5, because 3 and 2
I
that would mean
see.
that would mean
So
that we have 1, 2, 3, 2, 5,
so
right?
what you're
You see how this?
saying is the initial start, the way the rotation works is um 1, 2, 5, 7, 9. You
Uh huh.
rotate it 3 times, right?
Uh
So it
huh.
would be uh don't tell
Move
me.
the. Okay. Oh, sorry. 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 Sorry.
Don't
Sorry.
tell me.
No, I got you. I got you. I got you.
It would be 5. Hold up. It's one of these, but 5, 7, 9, 1, 2, or it's 7, 9, 1, 2, 5. Like it shifts it like
Mhm.
over. So
Yeah.
that's what rotating means. That's what they mean by that.
Yes. I think if you go back to the problem, it says so we get on the
One, two,
after
three, four,
the
five. Okay.
bullet points. I think it
Mm-hmm.
gives you an example with n-1. If you go up, 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 right there, right there. Here, notice the rotating array. Blah blah. One time results in a-1, a0, a1, a2, n-2. So basically,
I see what you're
um,
saying.
so n
Okay, that
minus
makes
one
sense.
moves to the front, and then the other ones move behind that. That you get me?
Yeah.
Yeah. So it's like a circle, like you
Yes.
rotate it,
Yes.
right? But it still keeps the same property.
It still keeps the same order. It's just moving.
Exactly.
It's just moving.
Exactly.
Yeah. I thought
Uh huh.
rotating it was like almost like shuffling them in random order.
Mm,
But no, that's not the case. It's
yeah.
like you said, it's a circle, just
Yeah.
rotating the stuff.
Uh huh.
Okay,
Yeah.
well then
That's what
yeah,
I got from it.
I
Yeah.
think then this does make a lot of sense.
Yes.
Is you got hmm wait,
Go for it. Go for it.
it makes sense, but what's some counter arguments?
I
If
was thinking,
this
what if it
go
was sorted? Like one, two, three, four, five. Right? Three is greater than one, so we're gonna move this way. You get me? And
Uh-huh.
we're losing one. So I think that's one counter argument that I got. You get me?
Yeah.
Yeah. So
Hmm.
I think we're trying to find the smallest. So I think that's an important thing to keep in mind. Trying to find the smallest, and it's in ascending order. That makes sense. So how can we find the smallest number using binary search in an unsorted array? Semi-unsorted.
Okay, well I have another counter argument.
All right, go for it.
You said, if I'm understanding you correctly, is there a laser on here? No laser. Okay.
I think there is no.
No, I think that's on oh yeah, yeah,
Uh,
yeah.
yeah, it is right there. Yeah,
Okay.
yeah.
You said that you're comparing 5, right?
Mm-hmm.
To 3. I
Mm-hmm.
just sneeze, hold up. I'm back.
Ah, good, buddy. Ah,
Okay.
good.
You're saying that you're comparing 5 to 3, right?
Mm-hmm. Mm-hmm.
If 5 is greater than 3,
Mm-hmm.
okay, that means you could say that there's a smaller number over here.
Yes.
And the counter argument I would say to that, if I'm understanding correctly, would be that if these two were actually 6 and 7.
Yeah, that's it. Yeah, that's what I was saying too. When it's sorted, it's a little bit not unfair, but it's a little bit like weird per se.
But how do you know if it's sorted?
Mm.
I
Mm-hmm.
like that. How do you know if it's sorted?
Mm.
So okay, so we know two things. We know that if it's not sorted, your pretty much your algorithm that your approach works. I maybe there's something we're not taking account for,
Maybe.
but
Yeah.
pretty much it works. Works. Did I spell approach wrong?
No. Wait. Yeah. 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 I think so.
Okay. If it's if it's um if it's sorted, we need to figure out how to tell. Need to figure out how to tell if it's sorted. Question mark, question mark. So
Okay.
how how can we do that? Chat the man said, have y'all been applying? Yes, I have.
Really?
Yes.
I haven't started yet, but I think I'm gonna start this weekend.
Bro, you have so much I have so much imposter syndrome. Talk about it, man. I'm here for you, brother. What's been going on? Why do you feel like you're an imposter? You know what imposter syndrome is, Jose?
I think so. I think I've heard of it
I
before.
think
It's like
isn't it like
when you like
you feel
diminish
like
yourself.
yeah, you feel like you're
Yeah.
not there.
Mm-hmm. Nah.
Uh, so what were we saying? We need to figure out how
Oh,
if it's sorted.
yes. Um, I would say to see if the approach works when it's not sorted, and then we figure out if it's sorted. What do you think about that?
Mm, or maybe there's a
Y-
one all be all like approach.
Okay. Jonathan, welcome to the stream.
What's up,
Imposter
Jonathan?
syndrome
Sus.
it is. Nah, man. Like the best to be honestly, when I get that feeling, Clat, you know, um, just learn the basics, the core basics, like to fully extend, learn like the algorithms, the data structures, really learn them. And if you can learn those, if you learn the basics with a good foundation, you can build any house, pretty much.
Hmm.
So you just get those foundations good, you can solve any problem, my boy. You know,
Jonathan said, which problem are we doing?
we are
We're
doing
doing 153.
find minimum in rotated sorted array. Yes, sir. Yes, sir.
So, to add to that, Clat, obviously I'm in no position to give you like the best advice, but here's what I'm gonna do, like for myself when it comes to trying to feel prepared. Is like Jose said, is making sure you build that foundation of various topics. Build that foundation. It's not easy, but practice those often is the work that maybe someone might have to put in order to feel like they're prepared enough to be asked any question. And the challenge is how you can infer to those problems you've solved that's going to solve your current problem that an interviewer gave you. How are the problems that you solved going? How can you infer the same pattern that you did over there? How can you correlate it to the current problem that an interviewer set for you? That's what I would say. I don't know if that's the best way for everyone, but
Yep. Yep.
that's just my opinion. Um, we need to figure out how to tell if it's sorted or what's an end all be all way to catch it. Is
Okay.
binary start? Is there any hints to the any
I
hints? Do you
think
wanna?
so. I think so.
Oh, okay. Do you wanna do a hint?
You tell me.
I'm down for a hint.
I'm down. I'm down. I'm down.
All right. Hint number one. Array was originally in ascending order. Note that the array is rotated. There would be a point in the array where there is a small deflection from the increasing sequence.
Okay.
The array would be something like 4, 5, 6, 7, 0, 1, 2. Hint number two, or
Ooh, go for it if you want.
you can divide the search space into two and see which direction to go. Can you think of an algorithm that has
Binary
O log
search.
n search complexity? Huh. You could divide the search space.
I think what that means is that one for example, there's two parts in the array that give us a 4, 5, 6, 7, 0, 1, 2. There's a deflection right between the 7 and the 0.
Yep.
One side from 4 to 7, it's the bigger side. From 0 to 2, it's the smaller side.
Okay.
You see, there's like those sides,
Yep.
right? And depending on what side we are in, depends where we can go. Does that make sense?
Depending on what side we're in, tells us where to go.
Mm-hmm. For example, if we're 4 and 7, right? 4 and 7, that's the big side, right? We know that for if we are rotated X amount, right? Even once, I know for sure that the middle and the left number, it's gonna be the biggest numbers, even if we rotate it one time, because the smallest number, which was found on the left side, got rotated all the way to the back of the right to the right. So I
Yeah.
know for sure from the left to the middle, right? If I know for that fact that it's smaller, it's bigger than the smallest. So we're not gonna
So
find the
go
smallest
to
there.
the right side.
So we go to the right. So we move the left pointer to 0 and the right pointer to 2. And now we got the middle at 1. You get me?
Okay. I think I'm
Yeah.
catching you. I'm catching
Yeah.
you. So we I like this array right here. I'm gonna take it
Mhm.
and I'm gonna
Copy it.
copy it over.
Just.
I think this isn't a bad thing right here, is to figure out to tell if it's sorted. So I think we
Yeah.
could, like how you said, cut it in half. You could tell, okay, if 5 is greater than 3, we could assume that the right side is gonna have a smaller number somewhere.
Exactly. Yes. Yes.
So if we know it's not sorted from like least to greatest,
Mm-hmm.
if we know that. But anyways, so this array right here,
Yeah.
let's fix that. So uh, 7, that's the middle,
Mm-hmm.
and you check 7 and 4.
Mm-hmm.
7
Yes.
is greater than 4.
Yes.
We know it's not sorted, like from least to greatest, correctly.
Yes. Because it got rotated. Uh-huh.
So we could firmly say this needs to move over here.
Uh-huh.
This is going to go all the way to the end.
Yes. Pretty much. Yes.
Now, let me change it up to where I can't select the text for some reason.
Oh, yeah, I got you. It's because I liked it. There you go. My bad. My bad.
It's okay, it's okay. So let's say 0. Uh,
Okay.
0. Okay.
Okay.
So we're here again. We got 0 and we got 4. 4 is greater than 0.
Yeah.
What would be the approach here?
Well, we ooh. Okay. I see. I see. I see.
And
Because we're
also, is there
actively
any negatives?
checking the constraints.
Yep.
N-
Wait. Yep. Yeah.
Ufas.
Okay.
Okay, that's good to know. Well, this 0 we can save it, right? Because our middle is gonna dictate if we have found the value, right? Left and right are just like the window. They're the shorting out the window, trying to like contain middle, right? But middle is your answer, right? It's gonna give you your answer. So we could contain like middle in a variable, right? the variable, and we can just like check if the following middle that we're gonna get, it's smaller or bigger. If it's smaller, we set that variable to that number. If not, we don't set it to that number, if that makes sense.
I see. So always store the middle target.
Yeah. What do you think? What do you think?
Huh. Now how do we know if it's
Uh-huh.
is the way to know if it's sorted from least to greatest or ascending order?
Yes.
Is it wrong to say that if the left is less than all the way at the right, that means it's an ascending order?
Yes. Yes. Yes.
So if you just check the first index and the last index, if the last index is greater than the last index element greater than the first index element, that means it's it's in sorted order.
Ascending. Yeah. Uh-huh. And I think if it's in a sorting order, we can just return the first element here,
Yes, the
whatever
zero
that
element.
is.
Yep.
Yeah.
And so then if it's not,
If
then
it's
we
not, we
do
can
this
use
algorithm.
yes. Yeah. Yeah. Yeah.
All right, I
So
like that. I like that. We're
all
onto
right. So
something.
let's check right here. Sorted. We say if left is less than right, return. Oh, just a little note. Little note.
Okay, okay,
Keep it in there.
okay.
Yeah. So that's how to check sorted. Now, if it's not sorted, yes.
Just
Hmm.
so we get the middle. We compare the middle to the first index, right?
Hmm.
Oh,
Hmm.
we store the middle and then we
Yes, I
compare
was
it.
thinking on storing in the middle. Yeah.
Store the middle, compare. If let's say this right here, oh, that's gonna mess up everything. Okay, so if zero is, we're checking if zero is greater than 4. Is that correct?
Yes. Essentially,
And then if
yes.
it's not, what happens if it's not?
If it's not, Wolfas. Zero is not greater than. Hmm. Let's see. Let's see. So if zero is not greater than 4, hmm. If zero is not greater than 4, 0 not greater than 4, we would move this way, I'm assuming? Because we got 0 saved already, right?
Yeah.
So we would move this way, right? And we got our middle here. This middle is gonna fit in right here. Oh no, that's not good. Hmm.
Huh. Oh. Wait a minute.
Yeah.
Wait a minute. You're onto something. So maybe instead of putting the moving this middle pointer or whatever you want to call it over, just keep it right there.
Mm,
Like, let's say we want to go to the left side. Yeah, we go to the left side. We this, and then like you said, you check left and right. Boom, left. That is in ascending order. Return this arrow.
I don't know.
I don't know. Cause wait. Yeah, cause if you check if left and right, check if left is less than right, the furthest on the right, every single time. Once you find that left is less than right,
Uh-huh.
um, mm, okay, let me do a different.
Let me lock it. Let me clear this. Let me clear this. This. Can I erase?
Oh, I unlocked it. I think.
Oh, I know. I think I locked it already.
Okay, do your thing.
Yeah, I'm gonna erase so we can.
I need another. A test case.
All right, go for it. Go for it.
I don't know how to unlock it.
It's on the. You could right click. It's on the second to last. Just unlock right
Perfect.
there. Yes, sir.
Okay, another test case.
Yeah, because all right. So
this would be. Sorry, go.
so I was because. Hmm. Hmm. I'm thinking. Okay. Yeah.
So we're at 1.
Mm-hmm. Let me move everything to the all this on the bottom thing to the left.
We're at 1. We check 1, 5.
Yeah.
1 is not greater than 5.
Yeah, 1 is not greater than 5. So we save 1. No?
Yeah, we always save the middle.
We all save the middle. Yes.
Well, I want to create a test case where 1 is right here. 1 is right there. But I need it to be.
Or you can delete the 7 and the 1 will be on the left. Yeah, right
That.
there.
So the middle is still the 1 though, or it's 2?
Oh, okay. Yeah, never mind. So I think you have to. You can do. No, 8 in the middle.
Am I dumb? How do I make it to where 1's shifted
You can move
over?
5 to the right. You can move 5 to the right.
Oh,
Now
okay,
you got
okay,
2
okay.
in the middle.
Yeah. All right. Okay, so yeah, I think this is a good test case. So 2's in the middle. 2 is not greater than 6. We can't say,
Yes.
okay, let's move this over here. Oh, 2 is less than 5. Return this. Return 2. Because that's not it.
That's the thing. That's the thing. So when 2 is less than 6, right? That means that the smallest value is found here. Because over here, this is 3 is bigger than 2. If we keep going to the right, we're just getting bigger, and closer to 6. Right? So for sure, now we move the left pointer, right? The right pointer over here, and the middle becomes 7. Now we start working with that.
Mm-hmm.
Actually, we move this pointer over here, like that, right? Because we know for sure if 2 is less than 6, we know for sure that's it. If we go to the right, we're just getting closer to 6. We want to go as far as we can go far from 6 because we want the smallest number. So it must be in this little square right here.
So in this test case right here,
This test case,
0
we
is
would
less
move.
than 4.
Yeah, we would move the
So,
right pointer all the way to 6, 4 to 6.
okay.
You get me? Because zero is already getting saved in a variable where we're gonna keep track
Okay. Yeah.
what middle values are smaller or bigger in 0. You get me?
Yeah.
So we can move our left pointer and our right pointer here and our mid pointer here.
Yeah.
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 Yeah. So that's the
I like that.
yeah.
So if the middle pointer or middle if middle is less than the first element, move to the left.
If middle, all right, let me see. If middle is less than the left element, move to the left. Move to the left. We have
Yes.
to move to the left. Yeah, move
If
left.
middle is greater than the left element, move to the right.
Yes.
Yeah.
If left
Right.
is
Perfect.
yeah, because we narrow it down because we know for a fact if middle is less than L, we know for sure it's gonna be there. The smallest number is gonna be there.
Yeah.
Yeah, we either saved it in the variable or it's gonna be in that little square.
And then we could always say we do one check in the beginning. Always say if left is less than the right, that's gonna tell us if it's sorted
Yeah.
or if it's in the correct rotation.
Yes.
All right, perfect. I think we got it going on. What's up, Kyra? How you doing? What's up?
Bro,
Oh, Jonathan
read
just solved it.
Jonathan's.
Just solved it. It's pretty annoying. Well, I like annoying. Let's get it
Look at
solved,
this.
Jose.
Yeah,
Let's
let's
get
get
it
it solved.
solved,
Let's
buddy.
get it cooking.
I'm interested to see the solution. If you want to post it in the Discord, Jonathan.
Oh, that's so true, Jonathan. Put it in Discord, Jonathan. That'd be great. We would love to see it.
Okay.
All right, so
So,
little pseudocode.
all right.
Would be
So,
if
check
L.
if L
Oh, uh huh.
less
If
than
L
R.
is less than R. No, M. Oh well,
Well,
this is
it's the
okay.
initial.
Yeah. My bad. Yeah.
Then return L or nums L. Right?
Mm-hmm.
That's the first check. It's only going to be run once. Right?
Well, but what if? I don't know if
I
it's
think
gonna
so.
help us though. All right, let's see. Yeah,
What's your
maybe
concern? I'm just sitting
it's
here.
because I was thinking putting it on the while loop.
So I'm always running each iteration.
Yeah, because what if we run into like what if a subarray? It's just like that where it's sorted.
But we showed that because it's sorted doesn't mean that that's the least element.
Oh, okay. I see. I get you. Okay, I think I get you.
I
Let's
think
see.
there
Let's
was an
see.
example. Look, let me see. Unless I was, it was. I don't know. Okay, what do you want to do on that one then?
No. Let's continue.
Okay,
Yeah. I'll
so
follow
then
you.
that
You can
runs
follow.
once.
Mhm.
Else, if there's an else, then it runs the rest. Is that correct?
Um, I think so. Yeah.
Or just no else. Just put wow.
I'd say while, no?
Yeah. So while
While left, I think it's left, less than, or equal to right. Yes.
Well, yeah.
Yeah. And then we have to get M, which is
Get M and store it.
yeah, which is L plus R divided by 2.
It's ceiling or floor of R minus L or
No, L
R
plus
plus
R divided by 2.
R plus L divided by 2. Yeah. Is it ceiling or is it floor?
Mm, floor. Floor.
Okay.
Mm-hmm.
And then if L is greater than M,
Yeah.
then move to the left.
Yes. Yes. Mm-hmm. Yeah.
Okay. And
Yeah.
then you store M. Oh,
We store. We have yeah.
if M less than or if curve less than M, then store M.
Okay. Yep. Yeah. Yeah.
Like that.
Yes. I like that. I like that.
Okay.
Yes. Mm. Okay. I think I like it. Yeah. I think I like it.
Yeah.
Yeah. Mm-hmm.
All right. Let's see. Come on. I'm feeling it, baby. Come on.
Just one thing, but I think it works. It will still work, but just I think it's the naming. I think cur should be M and M should be cur. Because you're saying get cur
Oh,
from yeah.
store curve or I know what you're saying. Store cur in M.
Yeah.
Get
And then
cur.
get M.
Where you
You
were?
get me? Right there. Yeah, get because I think you flipped them because you're saying get cur when it's
But we're
get
getting
middle.
cur. Cur is middle. I just put M as like the final, like
Oh, I see.
variable
Okay.
M.
Yeah. Alrighty. No, I'm just saying like for like naming purposes, I feel like it
Okay,
would be
so you
easier
want an
because
M?
then yeah.
Okay,
Yeah,
so
I
M.
get a little picky
Then
by guys up there.
what's this called?
That it could be cur. Yeah,
Why? But cur doesn't.
because cur is gonna save if well according to this, cur is gonna save the lowest value.
So then just put minimum.
Yeah, if you
Okay.
want to
Store M in
and minimum.
min.
Mhm.
Get M. Store M. If less than. Yeah,
Um.
M. Yep. Return min.
Uh-huh. Yeah,
Nice.
that works. That's
All
supposed
right.
to work.
Now let's get it going.
Yep.
Um.
All right, so I think we have to declare the variables
So
first.
L equals 0.
Mhm.
R equals nums. Oh, length nums. Yeah.
Minus one.
Minus 1.
Minus one. Yep.
Okay. If nums L less than R, I mean nums R, return nums L.
Mm-hmm.
Okay. I'm gonna put return first element if if nums in ascending is in
Ascending ASC.
ascending order. Okay. While L less than equal to R. I thought it was less than R, but I don't know. We want to get middle, which is M equals the floor of R plus. Is it math.floor or?
You want me to check that real quick?
Yeah.
I think it's just floor parentheses.
Okay.
No, math dot floor. Math dot floor. Yes, yes, yes. With lowercase m, lowercase f.
Yeah. Kobe, what's up, bud? How you doing, man?
Oh, yo, yo, yo. Welcome to the stream, Kobe.
Kobe Neal, baby. Okay. It's like this? Yeah.
Yes.
That looks about right.
Yeah, but I think it's lowercase m. Just
Lowercase m.
yes, lowercase
Okay.
m.
And then we want to say if m, we need to create a minimum. So min equals, min
Capital N.
num
You can do capital M, I think, no?
for a variable declaration.
Yeah.
Capital M.
Yeah, I think because I think min is a keyword, no?
Yeah, but like, isn't that like unconventional?
I mean, if you want to use min, I'm down. That's why I say capital M. But if you
No, obviously we
Yeah.
can't. We can't use this. Is what I'm saying.
yeah,
But
yeah,
like, I just always thought like doing the capital. Anyways, saving the country from foreign hacker. How's saving the country from foreign hackers? Hey, I'm not in that position right now, but let's say if I was, it would be going good. Still best in the biz. Hey, appreciate it. Me and my boy Jose right here.
Hey,
Me and
we
my
in
boy
here, we in
Jose, we
here.
doing it. We grinding, baby.
Yes, sir.
Um, why
Got
am
it,
I stuck
min.
on this, bro? I just want to name it
Minum.
something.
Minum, minum,
Minimum,
minum,
or just call it
minum.
minimum. I don't know, dude. I don't care. All right. If M is, like I get pissed off, bro, because I just want to name it something, but of course in our head, like it's instilled that we got to name it something correct, and it's just so
Yeah.
annoying. Anyway, sorry. I'm sorry.
I think for that statement, we can use the minimum function, like the min. We can set a min,
Ah,
num, equal to, yeah.
if min m min num,
Just
or
set,
no, just
yeah.
min
Uh-huh.
m.
Mm, You
Call me
still have to
dumb,
set
bro.
it to, set it to minimum
Min num.
equals, yeah.
All right, but
Man, so many
okay.
min and num, bro.
Yeah.
Going crazy in here. I don't
Then
know which one is which.
lastly, if L greater than M, if L, don't we gotta increment L? No,
No, no, no, no, no, no. That would
we
be
gotta
taken care
move
of,
it. We gotta move it to
depending.
the right here.
Yeah,
Okay, okay.
depending on the, yeah. But remember, it's the variable, so you have to do nums at L, nums at M, because L and M are indices,
Yeah.
so you have to get the value.
Oh,
So it'd be
that's.
nums at L. Yeah.
Hold up, dude. I'm having a brain fart.
Take
Nums
your
at
time. Take your
L
time.
greater than M. M is already a number. It's not an indice. So we just say M.
Well, M is an indice.
M is a number.
That is an indice.
That is an indice. Okay. So then right here
Right
is
there would
we need to
be
store
nums M.
nums M.
Uh-huh.
Okay.
Yeah. I didn't catch that. My bad.
Nums M. Perfect. Good stuff.
Mm-hmm.
Good stuff.
Colon?
Colon.
Yes, sir.
Now we know we need to move it to the left.
Nums.
How are we gonna move it over to the left? We
Well,
keep
we move. Uh-huh. We move right to equal to M plus 1.
M minus 1,
Plus 1.
but we're moving it to the left.
Yes. Because we're moving the R. Or minus 1. Minus 1. Yes. My bad. Yeah. Thank
And
you.
then left stays the same.
Yes, that's
I
the
see.
same.
Okay.
Then the L's is where we're gonna do the plus 1
L
with.
equals M plus 1. Right?
Yeah. Yes.
Alright, I'm getting it. Dude, I haven't done binary search in a while, bro. I don't know
Hey,
if
you're
you
good,
have,
buddy.
but I guess I
I
forgot it.
vaguely remember it.
Okay. Everything looks good. And
Alright. Just
then what's
one
up?
thing though. Min num it's equal to 0. So min num, our answer will always be 0.
Beautiful.
Yeah.
None
Yeah, so
or
I
what?
think that works. I'm not sure.
Okay. Good catch.
And return min num.
Alright.
Let's
Let's
see.
see. Come on. Woohoo!
Hey! What the heck? Oh, because it's non-type. Let me see. Uh, Give me one second. Okay, I got you. On line 27, yeah, that one you can do float, then parentheses, quotations, INF.
I never heard that.
All right.
Okay.
So I remember that because I remember when a professor said that in Python you can set variables to infinity.
Uh-huh.
So I was like, so I searched it up real quick, and it actually you can set up variables to
That is
infinity.
crazy.
So
That's cool.
yeah, yeah.
Okay. So we got number 1 right.
Mm-hmm.
Number 2 right, which is good. Number 3 right. We didn't get number 2.
Copy it. Let's see. Let's analyze it. Let's
We
dissect
want to
it.
do Excel.
Yeah.
I gotta sneeze again. Alright,
Huh?
we're here.
Okay. So our middle was here. Our left was here. Our right was here.
Uh-huh.
So 4, 7. Right. Well, our first condition where the
Is
ascending is not
left.
gonna match.
Yeah.
It's not gonna match. Right. So 7 gets stored in what is it called on min num, which is 7. It gets stored.
Yep.
7. Then 4 to 7, it's greater, so we move to the right. And to do that, my bad. We move this one over here, and we move this one over here, right? Now we have that 0 is less than 1, so we move this one over here. Well, first we check, right? This one becomes 1, right? Then we say, all right, left is less than 1, so we move to the right. And middle becomes 1, right?
Ah.
1, right?
We
1
didn't get
stays
to store
1.
0.
Yes, sir. And I think it has to do with the fact that we put the ascending
Left,
order outside.
left, and right is outside. Yeah,
Yeah, I think we did because that only check it one time. So, but what about the inside?
I see. That makes sense. That makes sense.
Hmm.
But I feel like there would be false. Like it would say, oh, it's left and right, and then it's not actually the lowest, the minimum lowest.
Mm. I mean, we can check
All right,
with
let's
the
try.
min,
What do you mean?
like with the min function. We can check if it's minimum. If it's minimum with
In
the
the
current
array?
one that we have, we would save it, and if not, it's like it doesn't. For example, 4 and 5 and 6, we get this case right. 4 and 5 and 6 is ascending, right?
Mm-hmm.
But it's 4 less than 1, or in this case less than 0. Well, no, right? So we don't store 4. We just keep going.
I see.
You get me?
All right, well, let's try it. Let's
You have
try
some
it, huh?
doubts. You have some doubts. Tell me. What
Well,
what what you
well,
doubt?
we're only gonna figure out those doubts when we try it.
All right, fair enough. Fair enough.
All right, so let's move this. We just move this. Do we need to switch it up a little bit, or?
I think we just have to switch up one thing, which is that I don't think we can return L, because if we return L, the left pointer, right? Um, even though the left variable is not less than the current one we have, we're gonna return it. If that makes sense. For example, v 4 and 7, 4 is less than 7, and it's gonna return 4.
Yeah,
But 4 is not the
not the
smallest.
smallest.
Exactly.
So how do we know it's not the smallest?
I think we use the min function the same way we did on line 40.
All right, let's try it. So I put this in the beginning, or
I'd say in the beginning, no? What do you
okay,
think? What do you think?
I would say so.
Yeah. And
And
then we just
then,
check the left, because if it's in ascending order, if it's in order list,
mm-hmm,
left is gonna be the the minimum.
like this.
Yes, 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 yes. And I don't think we can return anything. Let's see. Let's try it. Maybe. Hey, hey,
I'm not
hey.
too. You know what? Jonathan said it was an annoying question. I'm not sure that this is it. I need to find some test cases.
Go for it. Go for it.
Let's figure this out. All right, come on, lock in.
Just sir. Just sir. Just
Oh,
sir. Just sir.
oh.
Oh, do, 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 do.
Yo, whoa.
Hey, I'm
Where'd this
kidding. I'm
come from?
kidding. Kidding, bro.
Damn.
Confetti guns. Confetti guns.
Confetti. Okay, it's confetti. My bad, my bad. All right, let's try this. So violent all of a sudden. What happened over there in Laredo? Damn, dude, we're doing.
Mm.
All right, you ready to run it?
I'm ready to submit
Let's
it.
get it, baby. Come on.
Come on. Come on. Yeah. Yeah.
Hey,
Eh.
hey,
Eh.
hey,
Eh.
hey,
Eh.
hey.
Eh.
Good stuff,
Eh.
Jose.
Nah, it's all us.
Dude,
All us. All us.
wow.
You know?
That was pretty
Nah,
good.
nah.
I'm not gonna lie. That was
It
pretty
was both
good.
of us. Both of us. Both of us.
Look how nice it looks.
Mm-hmm.
So simple. I guess I was, we for the past two streams, we've been doing that hard problem, and like our solution was not a simple solution like this.
Yeah.
So having like just having us get another solution that's like fairly simple, as in code wise,
It's
is
pretty
makes me feel
nice.
good. Makes me feel good. Kyra said dub, and the result is
Yes, sir.
dub, baby. Come on, let's go. We got this. Lock
Thank
in,
you.
baby. Lock in.
Appreciate it, Kyra. Thank you.
All right.
All right, next
All right,
one.
Jose. Well, we gotta update our insane level. Remember.
Woo. Okay,
Remember.
I'm good. Yeah. Of course, of course.
All right. I'm gonna let you go first. Where are you at,
I'm
buddy?
like a, I'm at like a four. I'm at like a
Four.
four.
Okay. Okay. Okay.
Four, because it was a tough one trying to like figure out to go left to right. You get me?
Uh,
But other than that, I'm happy. My brain hurts a little bit here and there, but
it
I'm good. I'm good.
does.
I'm ready to go. Ready to go.
Okay.
Right?
I'm gonna give myself. I'm gonna be honest with you, Jose.
Uh huh.
I'm not just trying to front in front of the audience or anything like that. I'm gonna give myself a 3. I'm
Hey,
at a
that's
3.
fair enough. Hey, that's good. That's good. That's
I'm at
good.
3.
That's
It,
good.
it got the brain churning, you
Mm-hmm.
know.
Yep.
Um,
Yep.
so I actually really enjoyed that problem.
It was pretty
I
nice.
really enjoyed
I
that
liked it.
problem.
It was nice. It was
I'm gonna
nice.
give it a star. I'm gonna star it. I'm gonna just. All right, we got one more in the binary search. Uh, search and rotated sorted array. Okay, maybe it's a similar thing. Let's see what
Maybe.
happens. So I guess I could just move that. Oh, you want to see Jonathan's solution?
Oh,
Let's look in the
yes,
Discord.
that'd
Let's
be
look in the
nice. I think
Discord
he
real quick.
posted it. Yeah, he did. He did. He did.
Let's see.
Mm.
Oh, oh,
Okay.
okay. It looks like
Similar,
oh,
similar,
very similar,
but he did
but
some
he didn't
little.
have the thing we had right here. I don't
Yeah,
believe. Let's see. Put it
yeah.
right there.
Ooh, okay, nice. Uh,
So,
so we got all right. So he starts with his pointers
yep.
left less than R.
Mm-hmm.
Then he gets the middle. Then if M is less than R, M is less than R. If M is less than R. Okay.
Yep.
So okay, R equals M.
Same thing. Oh,
Okay.
R equals M though. Hmm.
Ooh. Well, in that case, because if M is less than R, for example, if let's say if 0, right, was a middle, right, and R is 3, 0 is gonna be the smallest number. So I think he's trying to keep that 0 with that M. He's trying to track that small value with the M. I don't know if that makes sense.
So you're saying. So you're saying. Nah, never mind. Never mind. I like
Okay,
it.
what
This
is it?
actually is really
Yeah,
clean.
it's
I like it a
it's
lot.
pretty nice. Yeah, yeah,
Good stuff,
yeah.
Jonathan.
Yeah.
Good
Thank you,
stuff.
Jonathan. Thank you.
All right.
Yes,
I'm gonna just
sir.
clean this up a bit. All right, going to the next problem.
I'm ready. I'm
We're doing
ready.
search and
Search and
rotated
destroy.
sorted array. All right, so we got the first one done. Let's get to the second one. All right, Jose, I'm gonna let you read this one,
I got you.
please.
I got you. I got you.
Appreciate you.
So we're doing number 33, search in rotated sorted array. And it says the following. This is a medium problem, by the way. And it says the following. There's an integer array num sorted in ascending order with distinct values. Prior to beginning pass to your function, prior to beginning pass to your function, nums is possibly rotated at an unknown pivot index from index k, where yada yada yada, such that the resulting array is yada yada yada. Oh, indexed, for example, 0, 1, 2, 3, 0, 1, 2, 4, 5, 6, 7 might be rotated to at a pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algorithm in O log n runtime complexity. Example 1, we're given an input of nums of 4, 5, 6, 7, 0, 1, 2 with a target of 0. The output is 4 because 0 can be found in index 4. Example 2, similar case, we're given an index of 4, 5, 6, 7, 0, 1, 2 with a target of 3. And the output is -1 because 3 cannot be found in the array. Example 3, we're given an array nums of which is an element 1 given a target of 0. 0 cannot be found in nums, so we return a -1. Okay. Okay.
I'm a little confused right here on example 1.
Uh-huh.
That's index 5. 0, 1, 2. Never mind. Never mind. Ignore
Never
what I
mind.
said.
Alrighty.
Ignore
Alrighty.
what I said.
I
Ignore
will,
what I
I
said.
will, I will, I will.
Just completely
Okay.
erase what I just said. All right.
Hey, nothing happened here.
All
Nothing
right. Just
happened
making
here.
sure. Just making sure.
Nothing happened here. Nothing happened here.
So it wants to find the pivot, what it says, right? Or
No, I
return the
think it's
index of the target.
mm-hmm. I
But
think
it's
you
just,
got
it's like the same similar thing where it says it's
yes.
rotated, it's
Uh-huh.
throwing the smoke screen, it's rotated.
Exact. I think
Find
so.
where it's at in the. Okay.
Yeah. Okay. I feel like this one is gonna be a little bit more complicated because now we're trying to find the specific number.
I don't necessarily think that.
No?
No. I think
Alrighty.
instead of saying the condition is m less than minimum num, then replace minimum num with m with the new m. In this case, if m is not the target, keep going. You're still doing the same splitting, the same half splitting that we've known. You're still doing that same thing. You're just saying if M is not target, then keep going. And once L and R cross, that means there's nothing. It's not in the list.
Okay. I see. I see. But I feel like, what if, right? Because we're getting based like if, the middle is if mid, right? The middle is greater than the left, we go to the right, right? What if our target was in that section, and because middle is greater than left, we move to the right and we skip over that
Well,
section and target is
remember
not there.
you compare it to the target. So if middle
Uh-huh.
is is less than target, then
Okay.
target is going to be on the left or one of those things.
Yep,
If
yep, yep, yep.
middle compared to target, you move to the left or you move to the right.
Okay, yes. Okay. Okay.
Or you could maybe be more specific and say if middle, like if 7, like let's say we're right here. If 7 is greater than 4, right? We know that then this side we're gonna get only elements that are less than 7, right? Is
Mhm.
that true to
Mhm.
say or no?
Mhm. Mhm.
Or
Yep.
are we saying are we gonna get only elements that are that are greater than or less
Uh
than 4? What's the right way to say it?
I think we just get lesser elements than, well,
Then
it's because
all
it
of this.
depends. Yeah, but it depends on the middle though.
Well, basically what I was saying was we like the same check. If 7 is greater than 4, we know that everything on the right side is gonna be less than these numbers, or we have a
Mhm.
good assumption. If
Mhm.
target is less than any, is less than any of these numbers or 4, then that means we could guarantee targets over here.
Just.
But
Yeah. Yep. Yep.
I think the best way might be just comparing middle with target. Or maybe that's my
Well,
assumption.
I think we can compare it and see if it's less than middle, we go to the left side. If it's
Yeah.
bigger than set, if it's hmm,
If it's greater than 7.
if
But
it's
we also
greater
need
than
to check.
seven,
We need to check which side is going to be the least values and the greater values. So that's why I still feel like we still need to look at
yes,
the left side, like the first element of the array.
yeah. Well, we can say if
Hmm.
yeah, because we still try. We still need to figure out which side is like the bigger side and which side is the lesser side.
Yeah.
Yeah.
Once we figure out the side,
We can
then we
determine
do
where to
the
go.
then we do middle, middle, middle. If it's not target, then boom, like that's it. So maybe the approach would look something along the lines of this. Uh, it would be it would be check middle with nums L. Figure out what side target will be in, and then from there you'll just do binary search over like just simple getting the middle. Then keep getting middle until you reach or don't reach target.
All of that's gonna be in a while loop.
I don't know how exactly we would put it, but like the approach would be just figure out what side it's going to be in, and then just keep finding the middle of that side. And you're eventually going to either find the target or not find it.
Yeah. It's because the thing is, right?
Okay.
What if the middle, right? You're saying if middle is less, if target is bigger in middle, go to the right.
If target is bigger than middle,
Mm-hmm.
go to the right. But I'm thinking we still got to look at L. Like we got to say if middle is greater than L, and then also add an extra condition that says and it's less than target or
And less than
something along
we
the
can say,
lines of that. That was in the
okay,
chat, baby. Thanks, Colby.
sir. Thank you. I was thinking, all right. So if it's middle, because my idea was all right, middle. All right.
Yeah.
Can we go to Scala? It's because I can't
All
really
right.
explain it. Can we go
I
to
got
Scala
you. I
Drawing
got
Pad?
you.
Yeah.
Let's go. Let's
Yeah.
get it. Is this the
This.
same
Let
one?
me. I think.
Yeah,
Is it?
it is.
Oh. All right. Let me
All
just
right. Lock it.
clear this one. Yeah, and then.
All right.
All right.
Right here. Right here.
So, for example, uh, right. Let me create another test case where we're gonna have 2, 3, and then we're gonna go 4, 5, 6, right?
Okay.
And wait. 4, 5. No. 4. No, wait. Give me 1 second. Let me. I have to think this out.
It's
2,
all good,
5,
man.
6. There we go. I like that, right?
Okay.
Let's say our target was 6, right? We're looking for 6. I'm just trying to understand. So if you're
Yeah.
saying if mid is less than target, right? So in this case, is 6 mid and then mid is 1. We move to the right?
I'm saying that we still do the same is mid greater than L, right? Because
Okay.
that method tells us which value numbers, well, it gives us a
Well,
good
what
guess
values?
of
Yeah.
what possible values are on the left and on the right side.
Uh-huh.
So
Okay. Okay.
once we know that, okay, mid is less than left, right?
Oh, we
That
then
means
compare it to 1?
that means you compare it to the target and say target's probably going to be on that side because it's those values are could have a greater uh hmm
Greater value?
yeah, it will have it will have or could have the target value in there. We know the target value will not be on the left side because those are all lesser numbers, if that makes sense. Like in target 6, we know
Mhm.
the right side, sorry, the right side is not going to have 6 in it because we know it's all less than. That's why I'm saying we could still follow the same logic that we created to figure out which half might have the greater or lesser numbers, and we compare that to the target. If target's going to be in the greater number side, then you go to that side. If it's going to be in the lesser side, you go to the lesser side.
Mhm. I see. I see. So we check. All right. So we check is mid is less. We check if mid is less than 5, which it is, right? And then we check if 1 mid is less than 5 and
So let me ask you a question. What does mid less than 5 mean in our previous code?
uh what is 5 less means
Like,
that there's the smallest numbers here
okay, okay.
in this little
Does
box.
would you also agree that it means that there's could be a greater number in there?
Yeah, yeah, yeah.
Because we know that the right side, hmm, because we know that the right side will be all less numbers, or
Yes.
so what I'm saying is if we know that the target's 6 and wait. Okay, I can see how this gets tricky.
Yeah, because if you say, all right, it's 6 here, but then how do you determine 6 in there? It's in there because you can say, all right, 1. If you go based on 1, if mid is greater than target, no, if mid is less than target, mid less than target, right? You can go to 6, but you can also go to 2 and 3 and 4, right? And then if you go, the only condition would be if target is bigger than left. You get me? I don't know if that makes sense.
Okay, then how about we answer this question?
Hmm.
The last, I hope it's maybe an easy, like, just a switch in logic, but the last problem we did, I'm comparing this to the last problem. I don't know if
Yep.
that's right or wrong or whatever,
No, yeah, for
but
sure. Yeah.
that's what I'm thinking. So the last problem was asking find the minimum number,
Hmm.
right? Now
Yes.
let's find the maximum. Let's find the maximum number. Let's say target is 6.
Hmm. Yes. But it's because I feel like the other problem, right, when we're trying to find the mid, we had the privilege to skip numbers, right? Because we weren't trying to find the specific number, right? So, for example, in this case, we would know that the smallest number would be here, right? But now we have to base ourselves on our target, right? Which can be vary because our targets could be lesser than left and bigger than one, or it could be bigger than left and middle, or they can be smaller than middle and left. You get me? Yeah or nay? Yeah or nay?
Okay, I might have found something.
All right.
If left is greater than right and middle is less than left, you could say that you could find 6 on the left side.
If left is greater than right.
If left is greater than right and middle is less than left, you could say if the target is 6, then that means 6 will be on this side.
Okay.
Or
What about
maybe,
two? What about two?
so if 5 is greater than 4 and 1 is less than 5, you know that 2 relies on the right side.
But what was the condition to find on 6?
Was that you know the furthest highest number that R goes to is 4,
Mm-hmm.
or that the right side is 4, and if the middle is less than the left, then that means there could be a higher number on the left side. If you know it's ascending order, remember 1 to 4, you know you're never going to hit 6, since 6 can't be in here. You're going 1 through
Yeah.
4. So
Mm-hmm.
you know that if there is a possibility that 6 would be in on the side, it would be on this side, because we know 5 is greater than 4, and then 1 is less than 5. That means there's a different, what was that, disillusion, what was that word?
Pivot.
Uh,
Yeah, I
there's
remember.
a
Yeah. Deflection.
there's a deflection right there.
Okay. I think I see you. I think I see you now. All right. I'm gonna propose you something similar.
Okay,
Let me see if you like
I
it.
think I was thinking of something else too that might make sense, but keep going.
Yeah. All right. So I like that idea. I like that idea. But what if instead of checking 5 and 1 and 4, we just check 5 and 1? What if our target is less than 1, it has to be here. If our target is bigger than 5, it has to be here, right? So we just narrow it right here. If our target is bigger than 1 and it's less than 4, our target is here.
Yes, 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 yes.
Yeah,
That's
you like
I was
that?
thinking the
You like
same thing.
that?
I was thinking something along the lines of that is, how about we just compare it to,
The left and
if
right.
T is obviously, if all the way on the right is 4, T, I mean 6 is probably not going to be
Yeah, it's
around
not gonna be
here,
there.
especially if 1 is in the middle. So we
Yeah,
know T is not. We know 6 is not going to be here. So yeah, you're right.
we can use it
That's
as
probably
boundaries.
that's the best way to say it, is
Yeah.
just check the middle and the left. Something along the lines of that. Yeah. I don't know. Write it again. All right.
If left is less than target, or target is less than middle, right? For example, 6 is greater than left, right? Because it's 5. So it would fit in this category. But for 0 be less than 1, right? So it fit into this category. So we know for sure 0 or 6, whichever we're trying to find, it's here, right? Yeah or nay?
I thought you could say if left is less than target and middle is greater than target or something, then you know it's on the left side.
If middle is greater than target.
Not I'm not saying
Well,
greater was the right way to say it, but like just saying if middle is greater or less than whatever the condition would be, then you know it's on the left side. Is what I'm saying.
oh,
Instead of
okay.
using
Oh, with
or.
an end. Okay, yeah. I think we just flipped the signs. Because I think it's the opposite. So if left is bigger than t,
Oh, I see what you're saying.
right? If left is bigger than t and t is greater than m, right? We know for sure t is not found there because t is less than l. So that means that a number less than 5, right? We got no numbers less than 5, right? Or t is greater than m. If t is
It's
greater than m,
yeah,
it has
it's
to be over
everything on
here.
the right side.
Yeah, so we
Yeah.
like exclude those in the middle.
Yeah.
Yeah. So if this is the case, right, we have to move to the right. Right? Because we know for sure our number or t is not found in here.
Mm-hmm.
Right? So we move to the right and check if it's over there.
I see.
Right? Yeah or nay, yeah or nay, yeah or
I
nay.
like it. I
You
think
like it?
I think something's there.
Something's there?
Yeah, for
Alrighty.
sure.
Else we move to the left. Yes? No? Maybe?
Yeah. Or if middle is already target, return middle.
Yeah. Yeah.
Beautiful. Well, we'll see. We'll see if it
We'll
works. I'm
see.
interested. I'm
But
interested
I
to
like
see.
it. I like it a lot. I like it a lot.
Okay. You're gonna have to guide me a little bit when it comes to the pseudocode. Let me see.
Nah,
Okay.
this is our pseudocode. This is a hard
Okay.
pseudocode. We
Yeah,
came
you're
up
right. You're
with
right.
Nah, but I got you, buddy. I
Okay.
got
So
you. No worries.
we said what's on Excalibur?
On Excalibur, we said if L is greater than T
So if
and
nums L
if nums at L, yeah,
greater than T
uh-huh,
target. Yep.
and T is greater than M being nums at M, move right. If you want, you can put move right there because it's pseudocode and we can like do the code.
For sure.
Yeah. And then else move left.
Now, whenever we know the side, how are we gonna do? Then we do the binary search from there.
No, I think this thing goes inside the binary search. It goes inside the while loop.
So, okay, so
Because
then let's express how we will go back to Excalibur. How
uh-huh,
do we
I'm here,
run
I'm
the
here.
same algorithm to get the target 6?
Alrighty, so now I'm gonna erase everything.
Or if you
Right.
want to do it on this example right here, this
Alrighty.
one,
Yeah,
we could
I
do it
got
on
you, I
this
got
one.
you. So we got our two little
Can y'all
pointers.
dunk? Hold on, hold on, hold on. We
Can
got
we
a
dunk?
question. We got a question.
Ooh.
Can we dunk? That's a very good question.
Ooh. Come on.
And you
Yeah.
could answer that question depending on like what you define as dunk. I assume you're talking about basketball.
I'm assuming you're talking about basketball too, and the answer for me is
So answer
no.
your question is no. That's the answer. Unless we're at a trampoline park.
Hey, some people are saying you can.
Huh?
Some people are saying you can dunk.
Kobe said he saved my family from a house fire. When he was walking away, he windmilled on the hoop in my driveway, just as like a
Like a
an
little
extra
extra
flex,
thing, like a
extra
cherry on
flex.
the top. But
Damn,
I can dunk.
that's funny. Clad
And no,
unsub,
Clad,
yo,
no,
yo, bro,
yo.
chill.
I better not see the counter drop.
Oh, hey, dude, don't tell him. Don't.
Hey.
Why are you saying my business like that?
You getting
Damn.
exposed over here. I didn't even know you had a Lambo, bro.
Why are you doing
Woo-hoo.
that? Stop it.
Woo-hoo.
I'm embarrassed. All right, Jose.
Alrighty.
How would you do it? How would you find
All
6?
right. For example, target number 1,
6 or
right?
1. Okay,
Number
let's do
6.
1.
Number 6. Let's do target 6. You
Okay.
said 6 first, though. Doing 6. All right. So, according to our pseudocode, we're gonna say, "Oh, I deleted our pseudocode. My bad." So,
You serious right now?
I am a little bit serious right now, but I got you. You can bring it back. There we go.
When he pulled out the keys, 50K fell out of his pocket. Yep,
Yeah.
true story.
All right. So, right. So we have it like this, right? We're trying to fire in target 6,
Okay.
right? So in here we're gonna say, all right. So 6 less than is left greater than 6? No, right?
No.
No. But 6 is greater than M. Well, it's not even greater than
No.
M. Ooh. We might
So
have
you
a
move
problem
left.
in here.
You move left.
Well, we move left. We move left.
Yeah, come
There you
on
go. I
now.
had a
Come
little,
on
had a
now.
little brain part.
Lock in, lock
Part.
in.
Had a little brain
Hold on,
part
let me
there.
erase this or stuff.
All
Right?
right.
We're
So
looking at the
yeah,
end. Okay.
yeah.
I got you.
So now we're here, right? In this while loop, we moved all the left. We left stayed the same. We moved right to n+1, and we kept them. And now we have a new middle, which is 5.
Okay.
So now we say, is left greater than 6? Yes. And
Wait, left is
target.
4 still.
Huh?
Left is
Yes.
4.
Left is 4 still.
So
Oh, yeah.
left is not greater than T.
Left is not greater than T. Yeah. So we move that. So we move to the left now, right? So our pointer, our little over here, right? So middle stays the same, and we move to the right.
Wait, so 4 is not greater
Oh,
than T,
wait,
and T is greater than M.
No,
You
we move
move
to
to
the
the right.
left.
Jose, you need to lock in, bud.
I have to log in, before. I have to
No,
log in. I'm
Jose,
sorry. I'm sorry.
we're
I'm
not
sorry.
moving to the left. We're moving to the right.
Left is no, because left is
Left is not greater than. Oh.
then T. So we
Oh,
move to
okay,
the left.
okay.
Yeah, you have to
But
log
that
in,
gives
my
us the
boy.
wrong. But now that gives us
That's
the
what I'm
wrong
saying.
answer. We're
Yeah,
cooked,
yeah.
bro. We're
We're
cooked.
cooked. Oh man.
Uh, hmm. Left, not greater than T, so that skips. But T is greater than M.
Yeah, but it's an end. So
But it's an
if one
M.
is wrong, then you're done for.
The aura. I guess I got aura.
You got the aura, my boy.
Yeah.
Yeah.
Mm. Dang, dude.
He's risky.
Uh,
Well, it's an
why can't
ascending
we just
order.
say? Why can't we just say we know the side it's on? So let's just
Mhm.
do find the middle. If the middle is not target, move to the right because you know middle is less than the target.
But what if middle what if 5, right, in middle, and over here we had a 0?
Then that means there's no the number is not in the number is not in the array.
Well, that is true. That is true. I take it back. I take it back. Mm, I mean, we can say that if 5, because the problem here is because now
Because
it's sorted.
the problem is that the first problem was finding what side this target could be on. We can now say which side it's on, but that doesn't mean we could use the same algorithm on to find which side it's on to find the target. We still gotta do uh just like a simple binary search once you find the side.
Mm,
I don't want to hear that from you.
I mean, I don't know, because, for example,
Okay.
right, we have uh 4. What is it? 5, 6, 7.
Yeah.
We're trying to look for 7, right? We do our little. We're trying to look for 7,
Okay.
right? And then 6 is less
Less
than
than t.
7, so we
So you
move to
move
the
left.
left,
Yeah.
right here. Are you gonna do binary search in here?
Yes.
How would that work?
You get the middle of the left and the right.
Mm-hmm.
The middle is going to be 7. In this case, that turns out it's the target.
But what if we had more numbers?
We still do binary search.
Just like a simple binary search?
Yeah.
But simple binary searches only work when they're ordered, though.
Okay, so let's say the order looks like this. What number, if you're looking for 6, 6 is less than 7, you're going to find 6. If you're looking for if you're looking for 1, you already know 1 was already on the right side. So you would already be over there. If you're looking for 8, you're like, okay, 8 is greater than 7. You move over. Oh, where's 8? It's not there. Oh, maybe because it's not in the array.
Fair, fair,
Now,
fair.
if you're looking for 0,
Yeah.
can we see test that out? Like how? Yeah, that's an issue right there. If we're looking for 0, then that's where the issue comes. So I agree with you.
Yeah. But also,
Right? If we're looking for
yes,
0,
yes, that would hurt too. That would be an issue too. But my main issue is like, because we can do a simple binary search here, right? But it would work on those 3, right? But I don't think it would work when those 3 become like 5 or 6 elements.
yeah. I mean,
Yeah.
I see a problem. Like, and then you're also expressing another problem that I don't quite understand, but I see a problem right there. Is that
With
if
the
you're looking
0?
for 0, our current approach would not, or my theory would not find 0 correctly.
Yeah. Yeah, because we need test cases, right? to continuously be able to like shift and move depending on where we are, right?
Mm-hmm.
And that continuously is gonna be given by us by a while loop, right? Because it varies depending at the where left is, where right is, and where middle is. Party.
You're pissing me off.
Me? What do you mean, bro? What do you mean?
You're just so
What do you
happy over
mean?
there, partying, dancing. This serious. We need to lock in.
I'm locked in. I'm locked in. I'm locked
No,
in.
I can't
Actually,
have you doing a party over there. What's up? What are you gonna say?
well, with this our way, it is good. We're gonna move left. If we're looking for zero, we're gonna move left.
Yes, that we
Yeah,
will correctly do that.
we will correctly move left.
Yeah.
I don't know if that was your doubt, but
No,
yes,
my
we'll move
doubt
left.
was how I mentioned that we just do binary search after,
Oh, mm-hmm.
and that wouldn't work. We wouldn't get zero.
Yeah.
Okay, well that's a good way to see it. At least we know we're going on the right side. Like we're choosing the correct side.
Mm-hmm.
And you're doing doodles.
No, I'm trying to think. I'm trying to think. I'm trying to think. Helps me like keep my brain,
Plat said,
moving.
y'all need to pop a Modelo and go crazy. Muy mal.
Hey, yo.
Muy mal.
Who said that? Who said that?
Plat.
Ooh, Plat. Ooh, no, no, no. Corona. Corona. Modelo, no, no, no.
Hey.
Hey, I'm kidding. I'm kidding. I'm
Hey.
kidding. I'm kidding.
Well, in that case,
Nah, I'm kidding. I'm kidding.
dang. Jose has a fake ID. Confirmed.
Nah, bro, that's confidential. It's
Well,
confidential.
you just ratted yourself out, but
Not even. I just mentioned one brand. That didn't mean I had anything. All right, all right. So we're gonna get here, right?
yeah.
But how do we move right though? Or in this case, right in here, how do we move right?
Okay. Well, let's follow. Let's follow the same thing we got. Like you were trying. Let's try to fix. Maybe it's something our initial algorithm is messed up. If left is greater than target, target is zero. So that is
Gee.
right. Left is greater than target. And T is greater than M. M is 7. T is not greater than M.
Mm-mm. So we're gonna move to the left, which is over here.
And that's wrong.
Mm-hmm. Or we can say, or we can also move right whenever T. Hmm.
Wait, 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 wait. Wait a minute.
Big step up. I'm waiting. I'm waiting.
Hear me out.
I'm hearing you out.
If we have a target, like let's say we get a middle. Middle, the first iteration of this middle is going to be 1, right? So mind you, we're over here. So middle is going to be 1. If 1 like 1 and 0 in ascending order, they're always going to be next to each other.
Mm-hmm.
Or 0 is always going to be behind, or let's say if they rotated it, it's going to be in front. So we know it's going to be either behind or in front.
Yeah.
It's a little bit, I mean, I don't know, but couldn't you say, okay, if 0 is behind or in front, then you found it?
Well, that's just for 0 though. But what if the target is 3, 4, 5?
Well, can you create a bigger array then? A bigger array that has the same dilemma, that
Yeah, for
it's
sure, for sure. I
less
got
than
you.
this, but there's a discontinue, whatever you call it. Whatever you call it. Yeah.
2, 3, 4, 5. 1, 2, 3. 1, 2, 3,
Hey, Clad
4.
wants you to teach the audience how to twerk.
Hey, yo! Chill out, Clyde. Chill out. 1, 2. Let me think I can delete some numbers in here. Yeah, Clyde is getting wild. Alright, so I think I added an extra number. So now 2 is in the middle, right?
I know you did all that work, but I decided just to.
Oh my
I'm
god,
sorry,
bro.
I didn't.
Oh my god, I should have told me earlier.
That's my bad. That's my bad. Right? That looks good.
Looks good, it looks good, it
Okay.
looks good.
Oh my god.
Oh my god.
All right. Oh, Jose.
Hey, that's good to hear, Clyde. That's good to hear. Unfortunately, I wasn't able to go to church today because I had to drive back to my Can we leak names? City names?
That's all, dude. That's all you, bro. You have to
That's how I
drive.
go. Oh, I had to
I
drive
don't
to
care.
San Antonio, Texas. So I couldn't. But I get you, Clyde. I go to church almost frequently. Almost, I try my best to do it every Sunday. And I get you. It's a very relieving feeling when you get out of church, and everything. And I'm gonna get a little bit religious, right? But hey, put everything in God's hands, my guy. He takes control. I've been learning how to do that, lately. Been helping me a lot. Just do your best, right? And there's a verse that says, "A horse prepares for battle, but God is the one that gives victory." So just prepare yourself and let Him do all the things, right? And you'll be fine. You'll be fine. Wait, I'm sorry if we're not talking about the same church. I'm sorry. I forgot to ask though. I'm sorry, but hopefully we are. All right, brother. All right. So, what do you think? What do you
Imagine, dude.
think?
Imagine.
What do you mean, bro?
You
You know,
assumed there was the same,
it's the same really, bro.
but
Thunder just goes on
imagine
me.
Clad just like goes off on you right now.
Oh,
Not
bro.
saying that there's like hostility, but just
Yeah.
imagine though. If,
Imagine that would be. Come on, go easy on me, brother. Go easy on me.
all
Go
right, all
easy on
right.
me. All right, all right.
So 0, or what's the target right here?
Let's do 0. Let's do 0.
Okay.
So we know 0 is not bigger than L is bigger than 0, right? And 0 is not bigger than M, so we're gonna go to the left, which is here, right? Um. Oh, my bad. Wrong thing. Right. So now we're over here. Again, 8 right now. 8 is the middle.
Mm-hmm.
0 is greater than 7. No, 0 is less than 7, but 0 is not greater than m. So we're moving to the left, right? Well, if you're here, right, you can do your binary search, but how are you going to do your binary search in these numbers?
Yeah, you can't. Yeah.
Because
Yep.
they're, so we still need to figure out a way to like solve that substring. You get me? So that's why again we have to go all the way back over here.
Wait, I actually got an interesting idea. What was the algorithm for our previous problem? We wanted to find the minimum.
Yeah.
Couldn't we use that to find 0, the minimum?
Yes, but what if our target is not the minimum? What if our target was 1?
What was the algorithm to find the minimum?
We determine if 7 or 8 is bigger, right? So if left is less than middle, go to the right. But a target, we cannot assume that a target is always going to be the minimum. It can be any number.
Wait a minute. If 7 is less than middle, or if L is less than middle, target's not going to fall in that. We know 0's not going to be in between that. So you go on the right side.
Uh-huh.
If left, so now you're right here. If what's the middle of this? 0
The middle, yeah.
of 2, right?
Yeah. Uh-huh.
Or is it 1?
It's 0. I think it's 0. You don't trust me?
No, it's not that I'm trusting now. I just thought of something else. You got to return the index.
Mm-hmm.
How are we going to do that? How are we going to find the middle of these two? Oh, no, I guess it still works. You can still get the index of this and this divided by
Yeah.
2 and you
At
get the
the
middle.
yeah.
It
Uh-huh.
doesn't have to be 0 and 1. You don't have to
No.
start the index at 0 or whatever.
No.
Okay, okay. So then when you have it like this, you're going to say is left. Oh, you're going to check middle. You're going to check middle. Is middle the target? And then, yeah, middle is the target.
Yeah.
So if you start from the beginning, stay with me now. Stay with me now.
No, I'm
We'll give
with
it.
you. I'm with you.
We'll
I'm
give
with
it a
you. I'm with
couple
you.
more minutes.
I'm with you.
We'll give it
I'm
a
just
couple more
thinking about it.
minutes. So is 7? We're looking for what? 0.
Yes.
Okay, we're
Yes.
looking
Yes.
for
Yes.
this. Okay, let's see. I might be wrong right here. If is 7 less than target, or 7 less, yeah, is 7 less than the middle? No. Okay. Okay, let's just follow the initial algorithm then. If left is greater than target, left is
Yeah.
greater than target, and target is less than middle, yes. Move. Wait. Oh,
No.
this is also a.
No. It's
Oh,
gonna move
target
left.
greater. Okay, yeah. So move left. Okay. Whenever you move left, it should be a different algorithm that says you get the middle of you move left, would it just be this right here, or would it be moved? This be moves over here,
It's
right?
gonna move on. Where's middle? Middle is.
Two.
Oh yeah, yeah, yeah.
This
Middle's
okay,
left. Right is gonna move
and
to the one.
then this is middle.
Yes.
Now you could say is 7
Well, we could do. Let me see. Let me see.
is
Let me see. Let me think.
is
I think I get you.
7
I think I get you.
7 you compare the middle with 7 with L. Now it's a different thing. So
Oh, I think. Uh,
is 7 less than 8? Yes, and we know 7 is the far left, like that's the
we
furthest.
we do the reverse. No? Or am I thinking wrong?
Like instead of comparing target, we compare it with M.
No. We Wait. No, never mind. Never mind.
What I was gonna think was like,
Because we can have. Oh, is finish? Finish. Sorry. I'm
oh
cutting you off.
no,
Go for it. Go for
I
it.
was gonna let you go. I like the direction. Like you seem very like you got something, so I'd rather hear you.
Well, we can do right. We're here, right? Where middle's here, over here, and over here. I'm rewriting them because on my screen you're whiting. It's gray.
Okay.
So not because to cover, not because I'm trying to cover anything. It's just
Nah, I see what you're trying
more
to do.
visual. Nah, what do you mean, bro? What do you
You know,
mean? What do you mean? So we have this, right? And then we're gonna say 7, 8. All right. We know for sure that if left, right? If left is less than no, if
left is less than middle.
no, if middle is greater than target and 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 left less than target and target no less than target. No, that doesn't make sense.
I mean, you could can't you just say if 7 is less than middle,
7
right?
is less.
So 7 less than 8. You know, let's just say there was you let's just say there's like imaginary numbers I I whatever, right? Let's say there's imaginary numbers in between 7 and 8 just for this point that I have. If 7 is less than middle, which in like I said for this sake it's 8, right? Even though it's technically not going to ever be the middle. But let's say it was that. You know that
It's not gonna be
anything
between 7 and 8. Yeah.
anything in here is not going to be the target.
So if middle is greater than target, yeah.
If I would say if
If left,
left is less than middle,
uh-huh.
then everything's on the right side. Wait. Sorry.
Okay.
If left is less than mid, and zero, and
Target.
and target can't be in that range of 7 and 8, right? Then that means and target is less than 7, then you know that target is not gonna be.
It's because I feel like this one, but what if we
You're
have
pissing me off.
something? Okay.
What are you gonna say?
Because what if we're not looking for 0? What if we're looking for a number in between 7 and 8?
That's why you check. Like you say it. Okay. Wait. Seven always gonna. Wait. Yeah, yeah. Okay. If there's something in between 7 and 8, you said,
Yeah.
or the left and the middle bound.
Yeah. I mean, well, it's going to be covered by this, no, by the top. Because let's say we have 7.5. Right. 7.5 is left is not greater than. Yeah, it's going to be covered by this. Okay, I take it back. So how do we move to the right? Did I make sense?
So can we? Are we agreeing, or are we kind of following the same approach that this top code right here is just gonna run once?
No, it's going to be run multiple times. Because we don't know, because that left, because if we run it one time, we're just assuming that we're never gonna move right or left, right?
No,
We
but
still need to.
you will still move right or left if you add another algorithm in between this, which is this.
Okay, yeah.
Like this will carry the work after that. This will find it inside. Is that log n though?
I mean, login is binary search, and we're gonna all of this. All these if statements are gonna be in a while loop.
Man, this one's actually pretty tough.
Yeah, because we're gonna do. I'm gonna write over here. We're gonna do while left is less than or equal to r, right? If while less is equals to r, we're gonna check if L yada blah blah blah. Right, move left or move right, move left, move right, move left, move right. You get me?
Yeah.
Yeah. Oh man,
I need to
this one is
update my
tough.
level. I'm gonna be real with you.
Go for it. Go for it.
I'm definitely above a 5.
Woo.
I'm gonna say 7. My
Um,
head just started hurting right there.
yeah, it's because this one works, but it only works. It's only gonna move left. But when does it always move left? When it's. What if it's inside? What if let's say we're looking for 8. 8 is greater than less. Left is like no. But let's say we're doing looking for 4. Left is greater and it's so we go to the right. Over here in the right, we gotta check.
Uh, mm,
What do you think? What do you think?
dude, I
This
got
one, this
stuck.
one hurts,
I
bro.
got stuck. And it
People
doesn't
in the
help that I have all this squiggly stuff that I
yeah, let me
drew.
clean it up. Let me clean it up. Let me clean it up.
I got you. I got you. Oh,
Oh, another one hits the dust.
was that me or
Control
was
Z.
that you?
I think that was you. Control Z.
Oh,
There we go. Let me lock it in. It's time to lock in. All right. So we know for sure this one. We decided we move right. We move left. Right. For sure.
but it doesn't work as a standalone algorithm.
Yeah, it doesn't work. brain hurts. Move left, move right.
You want to just play tic tac toe real quick?
We can, we can, we can.
All right. You go first.
Actually, let me. I got you. Oh, nobody won.
All right. I go first.
Yes, sir.
What am I doing?
Oh, I lost! I lost!
Oh!
Ah!
Hey, hey,
I
hey.
lost.
No, I want no, 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 no. No, 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 no. Bring that back. Bring the zeros back.
No,
I want the satisfaction of beating you. Thank you. Oh man. All right. That was a good break. Good break. Good break.
Alrighty. So it's because what algorithm do we need though? Because we figure out when we have to move right, when we have to move left. But if we
Oh,
already figure
Andy.
out
Sorry,
when,
Andy. I don't know how long you said that or when you said that, but which problem is this? This is
ooh, yeah, I think you
33.
search in rotated sorted array, my boy.
Sorry, Andy.
It's a
I
medium
will
problem.
I will take a picture of this and put it on the schedule draw.
Hey, if you're
Yep.
new here, Andes, drop a like, and drop a sub. We're close to our 400 subscribers.
There you go.
Man, bro.
All right.
Ugh.
Lock in. I know, man. I know we gotta lock in. What do you think, Jose?
Let me see. Let me run it through one more time. So we're looking for 0, right? We're gonna go here, 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 here. Left equals t is left greater than target, which is 0. Yes, and it's target greater than m. No, so we're gonna move left. Here, over here. Gonna delete that, delete that, delete this. So we got those. 0 is left. Okay. No. Else if mid is
No.
if mid is part of 0. Oh, mid is mm, so may caprista para tayo. Does this work?
If mid greater than T or T less than L, move right. Mid greater than T. Mid greater than T. Why would mid greater than T create a move right?
Because 8 is greater than 0. Or can we just say if t is less than L, right, move to the right. If it's greater than L, move to the left. Do you think that would work? Based ourselves on the left? What do you think? What do you think?
Okay, you're onto something. If T is less than L, I believe we can say move right.
Mm-hmm.
But
But
if
if it's not,
T is, you said if T is greater than L?
uh-huh. If t is greater than L, move to the left. But if it's less than L, move to the right. Because we know for sure if L, right, if it's less than L, right, that means that it's less than middle, it's less than left, so it has to be on the right side. So instead of all of this, right, we can do some like that, something similar to that. For example, we can do right in here, right, we can do, let me see. Okay, I can type here. So instead of this, right, we can do if let me see, give me a sec. So we know for sure. mm, I don't know, man. I'm tired. My head hurts. Dude, I hate these problems, bro. They're so weird.
I definitely think we need to come back to it. Obviously,
Yeah.
we. I think we need to let our brain rest. There's something about this problem that we're like overlooking something, or maybe
100%.
over complicating it. Damn, even Cairo said call it. Nah,
Yeesh, bro.
call it. Y'all are cooked. Oh,
Bro,
brother.
no. Who said that? Oh,
Kai.
man.
Oh, you're pissing me off.
Bro.
We're cooked.
We're overcooked.
Oh, Jose.
Uh, uh,
You
uh,
wanna play
uh.
Overcooked? It's
It's
$5.
$5, bro. What the heck? I thought
Yeah.
it was more expensive.
Well, I know a way.
Hey,
Okay.
yo.
What are
I'm
you
kidding.
talking about?
What do you mean you know a
Don't worry
way?
about it. You know those flea markets? You know how
Oh,
you
yeah, yeah.
you know
Uh-huh.
how like oh this is what I experienced. I don't know how they are now. But
Uh-huh.
flea markets they used to have those pirated CDs back in the day. Like
Mm-hmm.
the Shrek, the Incredibles, they all have all the CDs. Think of it
Yeah.
like that, but online.
Okay.
But not illegal. But also
Okay.
not illegal.
Okay.
When's the last time you gone to a flea market?
Ooh, a long time ago, like
Really?
7, 8 years. Yeah.
Wow,
Yeah.
why?
Yeah.
What's going on?
I never really went. Not because I don't like it or anything. It's just
Uh-huh.
I don't know. I never had the opportunity or the time to go.
Okay.
Yeah, but I mean, I'm down to go. I heard you can find really cool things in there for like very cheap price and stuff. So yeah.
Uh, oh, we got an op in the chat
Hey, keep it
trying to
peak. Hey.
keep it on the
And
low.
yeah, keep it on the low. It's an ABC conversation. You
Yes.
guys are the C. There's no D, E, F, G. I don't know how many
So
letters are in
yeah,
there.
it's an ABC conversation.
Yeah.
See your way
ABC.
out.
Ooh.
You know what I'm saying? You never heard that before? I'm not
Nah,
taking
nah,
credit for that. You never heard that?
nah. Never heard that
What?
before. Yeah,
Okay.
never.
Well,
But ooh,
I'm not
bro, you
taking
were
credit for
cooking
that
in there.
because it's been said. All right, Jose. Why?
Alrighty.
You think that's it?
I'm pretty cooked in here. I'm looking at around 7 to 7, pushing to 8.
7 pushing 8.
Yeah,
Yeah.
cause it's like we have. I think we have half of it, right? We just need the other half.
Yeah. Now we're getting accused. We win Hollywood. Here we go.
Yeah, we all went to Hollywood.
We win Hollywood. Apparently.
Not
You know what that
even.
means or no?
Yeah, like we went up high. Like we
we
got the fame,
changed.
got the best of
We
us.
changed.
Not even. Not even. We still in here though. We still in here. You know what I mean?
Every week we grinding,
Every
baby.
week we grinding. We grinding.
Man. All right. I mean, I have
All
nothing else to
right.
say other than like that problem is definitely
It's a tough one.
it's very
It's
tough.
it's very tough, bro. I
But I'm
don't.
glad we got that other medium problem done.
Oh
I
yeah, for
liked it a
sure.
lot. That was a good one.
Pretty
Um,
nice. Pretty nice.
but yeah.
Hey, we halfway there, bro. Then we link. I feel linked lists are gonna be a little bit better.
Yeah, I
No,
hope so.
because we got a reverse linked list, merge two sorted list, which I think we've done before. Those two problems. So I think we're good. I
But
think we're
then
good.
there's merge case sorted
Click on
list.
it. Let's see. Let's see. Let's see.
That's GG's.
You're given an array of k linked list. Ooh. Okay. And sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. We might be cooked. We might be cooked.
That
So
might be GG's.
we're giving a list of linked lists. That's tough. Hey, thank you, Kyra. You too. Enjoy your Labor Day. Chill. Rest up. Sleep late. Wake up late. Take it easy. Take it easy. Damn, that's a
Yeah.
tough one. Ufas.
And then you
Ufas.
got
Ufas.
trees. I think
Ufas.
these are okay. We could do these easily. Don't know about this one. Oh, this one we could probably do. This one we could probably do. I don't think I've ever done these. And obviously,
Those hard ones.
these, I've never touched those before. Oh, man. All right, Jose.
Hey, we're getting there. We're getting there. We're gonna get there.
Yeah. All right, Jose.
Alrighty.
I have nothing else to say, but
Me
enjoy your Labor
neither.
Day.
Hey, thank you, buddy.
If
Thank
it's something to
you.
celebrate, I don't know. Just do whatever.
I got
Um,
you. I got you.
I think that's about it. We'll be back
Yeah.
next week. Me and Jose are trying to figure out a time that we could always set with this new school schedule. So I think we said either Thursday or Sunday or like the most probable options
Yeah.
for times,
Yep.
but
Yep. Yep.
nothing's ever set in stone. So we recommend the Discord. We do the announcements usually the day of. Should we do the announcements maybe a few days before? Absolutely, but
Yeah. But I mean,
sometimes we got
things
things to
changed.
do.
Yeah, things
We got
changed.
things to do.
Yep. Yep.
But other than that, that's about it. I think
I'm
this was
good
a good
too.
week. We got to solve a problem, pretty
Yeah.
good, and Looking forward to seeing how we gotta solve this next one. From there, we're on to trees. So, oh no,
Linked
linked
list.
list.
Linked
We're on the
list.
linked list. So we just got one more to solve, and we're on to linked list. So
Ooh-hoo-hoo.
that's about it.
That's
That's all
about
I have
it.
to say, Jose.
Same here, same here. I'm good. I'm good. You guys enjoy. If you guys celebrate Labor Day, enjoy your day. And yeah, thank you guys for tuning in. Thank you guys for everything, and just thank you guys, and have a great, wonderful day, evening, night, morning, whatever it is, wherever you guys are living. We just thank you for coming in. That's it. I'm
Yeah.
good to go, my boy.
All right, everyone.
Yeah.
We'll see y'all
All right.
next
Take
week.
care. Bye bye.
Bye. All right.
All right. That was a good stream. I liked it. I
That was
liked
pretty
it.
good.